Some structures defy logic, not because they are beautiful, not because they are ancient, because the mathematics say they should not exist, because the tools required had not been invented yet, because the civilizations that built them should not have possessed the knowledge, the precision, or the engineering capability to pull off what they accomplished. And yet the stones are standing, the measurements are perfect, the alignments are exact. This is not about monuments that impress us. This is about structures that should have been impossible. Drop a comment right now telling us which ancient civilization you think was the most advanced. We want to see how many different answers this pulls. And pay attention when we reach number 3. The engineers who analyzed it said the tolerances were tighter than what modern construction achieves with laser-guided equipment. They built it over 4,500 years ago. Let's start with the structures that should not exist. 15. Sacsayhuaman, Cusco region, Peru. On a hillside overlooking what was once the Inca capital sits a fortress made of stones so large that Spanish conquistadors thought they were looking at the work of demons. Some of these limestone blocks weigh over 200 tons. They fit together without mortar, and the joints are so tight you cannot slide a piece of paper between them. The surfaces are not flat. They are complex interlocking shapes, each stone cut to match its neighbors with absolute precision across multiple irregular planes. The Inca had no iron tools, they had no wheels, they had no written language to preserve engineering plans across generations, and yet they transported stones weighing as much as a fully loaded 747 up a mountainside and shaped them with tolerances measured in fractions of a millimeter. Modern engineers have attempted to replicate the technique using period-appropriate tools. They cannot. The stones at Sacsayhuaman have survived earthquakes that leveled the Spanish buildings constructed on top of them. Whatever technique they used distributed seismic force in ways we still do not fully understand. At least the Inca left us something to study. The next civilization left almost nothing but the structure itself. 14. Göbekli Tepe, Şanlıurfa Province, Turkey. This is not just old, this is older than agriculture, older than pottery, older than the wheel. Göbekli Tepe was built around 9600 BCE, which places it roughly 6,000 years before Stonehenge and 7,000 years before the pyramids. At the time of its construction, humans were supposed to be hunter-gatherers living in small nomadic groups. They were not supposed to be organizing labor forces, carving multi-ton limestone pillars, or designing circular temple complexes with astronomical alignments. The pillars at Göbekli Tepe are decorated with intricate carvings of animals: foxes, lions, scorpions, vultures. The detail work is not primitive. It is sophisticated, stylized, and consistent across dozens of pillars. Each pillar weighs up to 20 tons. There are no nearby settlements from that period large enough to support the workforce required. Archaeologist Klaus Schmidt, who led excavations at the site for 2 decades, estimated that moving and erecting a single pillar would have required hundreds of people. The site contains at least 20 circles. Most are still buried. No one knows who built it, why they built it, or how a pre-agricultural society managed the logistics. And then, around 8000 BCE, they buried the entire complex on purpose. They filled it in with debris and walked away. Göbekli Tepe raises questions we are still trying to answer. The next structure answers questions with mathematics that should not have been available. 13. The Antikythera mechanism, recovered from a shipwreck off Antikythera, Greece. This is not a building, it is a machine. A bronze device pulled from the seafloor in 1901, dated to around 100 BCE. For decades, no one understood what it was. X-ray imaging eventually revealed a system of at least 30 interlocking bronze gears inside a wooden case. It is an analog computer. It predicted eclipses. It tracked the phases of the moon. It modeled the irregular orbit of the moon using epicyclic gearing, a technique that was not supposed to appear in human engineering for another 1,500 years. The gear teeth are triangular and precisely cut. The mechanism accounted for the Metonic cycle, the Callippic cycle, and the Saros cycle, all of which require long-term astronomical observation and mathematical modeling. Historian of technology Derek J. DeSala Price, who studied the device for years, called it more complex than any known instrument from the next 1,000 years of human history. If the ship had not sunk, we would not know this level of Greek engineering existed. Nothing else like it survives. No text describes how to build one. No other mechanism from that era comes close. We have one data point, and it suggests the ancient Greeks were building technology we thought belonged to the Renaissance. The Antikythera mechanism was lost at sea. The next structure was lost under the sea. 12. Yonaguni Monument, Ryukyu Islands, Japan. In 1987, a dive operator found something off the southern coast of Yonaguni Island. Massive stone structures sitting 25 meters below the surface. Flat terraces, right-angle corners, step pyramids, channels carved in straight lines. Marine geologist Masaki Kimura has spent decades surveying the site. He argues the structures are man-made, shaped by tools, and submerged when sea levels rose at the end of the last ice age. If he is correct, the Yonaguni Monument was built over 10,000 years ago, before any known civilization in the region possessed the ability to work stone on that scale. The formations include a structure resembling a step pyramid, approximately 75 feet wide and 25 feet high. There are stones that appear to have been stacked. There are post holes. There are drainage channels. Skeptics argue the formations are natural, shaped by erosion and tectonic activity, but natural geology does not typically produce parallel 90-degree angles, and it does not carve symmetrical staircases. The debate continues. If the structures are artificial, they predate the oldest known Japanese civilization by thousands of years. If they are natural, then nature occasionally mimics architecture with unnerving precision. Yonaguni sits underwater. The next site sits under a city that has been continuously inhabited for over 8,000 years. 11. The Hypogeum of Halsaflieni Paula, Malta. This is a subterranean temple carved entirely out of limestone bedrock. It goes down 3 levels. It contains chambers, halls, niches, and passageways spreading across roughly 500 square meters. It was built between 4000 and 2500 BCE using stone tools and antler picks. The builders had no metal. They had no blueprints. They worked in the dark, carving rock by hand, and somehow maintained acoustic properties across multiple chambers that amplify sound at specific frequencies. In the oracle room, a voice speaking at around 110 Hz resonates throughout the entire structure. Researchers have tested it. The frequency matches the range that affects human brain activity. Whether this was intentional or coincidental, no one knows. But the precision required to carve an underground temple with consistent acoustic resonance using only hand tools is staggering. The ceilings are carved to mimic corbelled stonework. There are decorative spirals carved in relief. Over 7,000 bodies were found inside when the site was discovered in 1902. Workers accidentally broke into it while digging foundations for housing. If they had dug 3 meters to the left, the hypogeum might still be hidden. The hypogeum was carved downward into stone. The next structure was carved sideways into a cliff face, and no one can explain the tooling marks. 10. Lalibela Rock-hewn churches. Lalibela, Ethiopia. King Lalibela commissioned 11 churches in the 12th century, and his workers did not build them. They carved them. Each church was cut downward out of a single piece of volcanic rock. They are not constructed, they are sculpted. The Church of St. George is a cross-shaped structure standing 15 meters high, carved entirely from the bedrock beneath it. The workers dug trenches around the shape of the building, then carved the exterior, then hollowed out the interior. Windows, doors, columns, arches, all carved from the same continuous stone. There are no joints, there is no mortar. The entire building is one piece of rock that was there before they started. Some of the churches are connected by tunnels. The tooling marks inside those tunnels are consistent and precise, angled in ways that suggest knowledge of load distribution and structural acoustics. Medieval Ethiopian builders had iron tools, but the speed and scale of the work does not match the timeline. Oral tradition says angels helped with the carving at night. Engineers say the labor force would have needed to number in the thousands, working in shifts for decades. No contemporary records describe the construction process. The churches simply appear in history, fully formed, carved from stone that has been there for 25 million years. Lalibela was carved by hand. The next structure was cast in concrete, which is impressive, except the concrete was poured 2,000 years ago and it is stronger than modern formulas. 9. The Pantheon, Rome, Italy. Finished in 128 CE under Emperor Hadrian, the Pantheon has the largest unreinforced concrete dome in the world. It spans 43.3 meters. It has stood for 1,900 years without cracking, without significant repair, and without reinforcement. Modern concrete begins to degrade after 50 years. Roman concrete gets stronger over time. The dome weighs 4,535 tons, and it floats on a ring of precisely engineered compression. The oculus at the top is 8.2 meters wide, open to the sky, and it has never compromised the structural integrity of the dome. The concrete formula used in the Pantheon includes volcanic ash from Pozzuoli, which reacts with seawater and lime to form a mineral called aluminum tobermorate. This mineral continues to grow and reinforce the concrete for centuries. Researchers at the University of California, Berkeley analyzed samples and confirmed that the material is still crystallizing. We only rediscovered the chemical process in 2017. The Romans were using it routinely in the 1st century. The Pantheon is not just old, it is better engineered than most modern dome structures. If you tried to build an unreinforced concrete dome that size today, engineers would tell you it is not possible. And yet every morning, sunlight pours through the oculus and moves across the interior like a sundial, just as it did when Hadrian walked beneath it. The Pantheon shows Rome's engineering at its peak. The next structure shows what Rome built in its conquered territories, and the logistics still do not add up. 8. Baalbek Temple Complex, Baalbek, Lebanon. The Roman temple at Baalbek sits on a foundation made of stones that the Romans did not cut. The Temple of Jupiter rests on a platform that includes 3 limestone blocks known as the trilithon. Each block weighs approximately 800 tons. They sit 6 meters above ground level. They were transported from a quarry 800 meters away and placed side by side with joints so tight that a razor blade will not fit between them. A fourth stone, still in the quarry, weighs 1,200 tons and is the largest hewn stone block in the world. Modern cranes can lift around 20,000 tons under ideal conditions, but they cannot maneuver a 1,200-ton block with millimeter precision onto an elevated platform without modern load-distributing equipment. The Romans built the temple on top of the foundation, but they did not build the foundation. Archaeologists attribute the megalithic base to earlier Phoenician construction, but there is no record of the Phoenicians moving stones of this size, and no other Phoenician site demonstrates this capability. The stones are simply there, placed with a level of precision that suggests knowledge of leverage, counterweights, and possibly friction reduction techniques we have not identified. No ancient text describes the method. The trilithon has been sitting in place for at least 2,000 years, possibly longer. Baalbek used stones that should have been immovable. The next structure used math that should not have been discovered yet. If you are still here, hit subscribe and turn on notifications. The rest of this list includes precision that we cannot replicate, alignments that require knowledge we did not think existed, and one structure at number 1 that uses a construction method we still have not figured out. A stone sphere polished to a tolerance of 2 micrometers. A monument aligned to celestial events thousands of years in the future. And a set of jars that should not exist in any material made with any tool at any point in history. Keep watching. 7. Newgrange, County Meath, Ireland. This is a passage tomb older than Stonehenge and older than the Egyptian pyramids. It was built around 3200 BCE. The structure is a circular mound 85 meters in diameter, retained by a ring of 97 stones, some of which are carved with intricate spirals. The passage inside is 19 meters long and leads to a central chamber with a corbelled roof that has remained waterproof for over 5,000 years. Once a year on the winter solstice, sunlight enters through a narrow opening above the entrance called the roof box. For exactly 17 minutes, a beam of light travels down the passage and illuminates the floor of the inner chamber. This alignment is intentional. It requires precise measurement of the sun's position relative to the Earth's axial tilt, calculated over years of observation. The people who built Newgrange had no written records, no metal tools, and no formal mathematical system that we know of, and yet they built a structure that tracks the solstice with accuracy measured in minutes. The roof box was discovered during restoration in the 1960s. For thousands of years, the alignment was forgotten, but the structure remembered. Newgrange tracks the winter solstice. The next structure tracks the equinox, the solstice, and the movements of Venus, and it does it with architecture. 6. Chichen Itza, Yucatan Peninsula, Mexico. The pyramid known as El Castillo was built by the Maya around 1000 CE. It has 91 steps on each of its 4 sides, plus 1 step at the top platform, totaling 365. 1 step for each day of the year. Twice a year during the spring and autumn equinoxes, the angle of the sun creates a shadow on the northern staircase that looks like a serpent descending the pyramid. The shadow aligns with the carved serpent heads at the base. The effect lasts for approximately 3 hours and requires the pyramid to be oriented with precision relative to the sun's path. The Maya had no instruments we would recognize as surveying tools. They used observational astronomy and mathematics, including the concept of zero, which they developed independently. The pyramid also functions as an acoustic instrument. Clap your hands at the base of the staircase, and the echo sounds like the chirp of a quetzal bird, a creature sacred in Maya religion. Archaeologists have tested this repeatedly. The acoustic effect is consistent and appears to be intentional, designed into the angle and material of the steps. El Castillo is not just a pyramid. It is a calendar, a celestial marker, and a resonance chamber built by a civilization we used to call primitive. Chichen Itza uses astronomy and acoustics. The next structure uses geometry so precise that modern surveyors cannot find the error margin. 5. The Great Pyramid of Giza, Giza Plateau, Egypt. You know this one, but you may not know the details that make it impossible. The Great Pyramid was built around 2580 BCE for Pharaoh Khufu. It originally stood 146.5 meters tall and was made of approximately 2.3 million limestone blocks, each weighing between 2.5 and 15 tons. The base covers 13 acres. The 4 sides of the base are aligned to the cardinal directions, with an error margin of less than 0.05 degrees. The sides of the base are level to within 2.1 centimeters across a distance of 230 meters. That is a deviation of less than 1%, achieved without laser levels or digital instruments. The blocks fit together with seams averaging 0.5 millimeters. Modern construction standards allow for tolerances 10 times larger. The pyramid was the tallest man-made structure in the world for over 3,800 years. Egyptologists estimate it took 20 years to build, which means workers would have had to set one block every 2.5 minutes, working 10 hours a day every day for 2 decades. The internal king's chamber contains granite beams weighing up to 80 tons, transported from Aswan over 800 kilometers away. No written records describe the construction. The tools we have found, copper chisels, wooden sledges, stone hammers, should not have been capable of this. And yet the pyramid is standing. The Great Pyramid was built with precision we can measure but not explain. The next structure was built with stone balls we cannot make. 4. The stone spheres of Costa Rica, Diquis Delta and Isla del Caño, Costa Rica. Scattered across southern Costa Rica are over 300 stone spheres, some weighing up to 15 tons and measuring over 2 meters in diameter. They are made of gabbro, a hard igneous rock. They are nearly perfect spheres. In the 1930s, workers clearing land for banana plantations started finding them. Archaeologists arrived soon after. The spheres date to between 600 and 1000 CE, created by the Diquis culture. Some spheres have been measured with a deviation from perfect roundness of less than 2 millimeters. Creating a sphere that size, that accurate, requires controlled removal of material from all directions simultaneously. Modern sculptors use computer-guided tools and diamond-tipped instruments. The Diquis use stone tools. No one knows how they achieved the precision. No one knows what the spheres were for. Some were arranged in alignments. Some were placed in front of important structures. Most have been moved since their discovery, so the original positions are lost. A few remain in situ. Archaeologist John W. Hoops has studied them for decades. He has stated plainly that we do not know the method. The spheres exist. The precision is measurable. The technique is missing. Costa Rica's spheres were carved by hand. The next structure was carved out of a mountain and contains details that should require magnification to produce. 3. The Kailasa Temple, Ellora Caves, Maharashtra, India. This is not a building. This is a sculpture. The entire temple was carved top-down out of a single basalt cliff. Workers started at the top of the rock face and carved downward, removing an estimated 200,000 tons of stone. The temple is 32 meters tall. It covers an area twice the size of the Parthenon. It includes courtyards, halls, staircases, pillars, towers, and life-sized elephants, all carved from the same continuous rock. The construction is attributed to the Rashtrakuta king Krishna I, completed in the 8th century. Traditional estimates suggest it took 150 years. Modern historians think it was finished in under 20 years. If that timeline is accurate, workers would have had to remove approximately 27 tons of rock every day for 2 decades. The details are microscopic. There are intricate carvings of deities, dancers, animals, and floral patterns covering nearly every surface. Some of the relief carvings are less than a centimeter deep. The pillars inside are load-bearing and perfectly vertical, carved freestanding out of the mountain itself. Engineers who have analyzed the structure say the margin for error was 0. If workers removed too much material from any load-bearing section, the entire temple would collapse. There are no mistakes. There are no corrections. The temple was carved once in sequence from the top down, and it has stood for over 1,200 years. Architect and historian Percy Brown called it the most remarkable single work of art executed in India. Kailasa was carved with tools and time. The next structure was built with blocks so heavy that modern machinery struggles to lift them, and the builders left no record of their methods. 2. Pumapunku, Tiwanaku, Bolivia. This is part of a larger ceremonial complex near Lake Titicaca, built by the Tiwanaku civilization around 600 CE. Pumapunku contains some of the largest stone blocks ever used in construction. One block weighs 131 tons. Several others weigh over 80 tons. These blocks were transported from quarries 10 kilometers away. The stones are andesite and red sandstone, both extremely hard. They are cut with flat surfaces, right angles, and intricate interlocking joints. Some blocks have precision grooves less than a millimeter wide. There are no chisel marks. The surfaces are smooth. The corners are sharp. Modern stonemasons who have visited the site say the precision would be difficult to achieve with current technology. The blocks interlock in ways that suggest modular construction. They were designed to fit together like puzzle pieces, carved in advance to tolerances that allowed no room for error. There is no mortar. The weight and the precision hold the structure together. The Tiwanaku had no written language. They left no diagrams. They had no iron tools. And yet they shaped some of the hardest stone on Earth into geometric forms that look like they were machined. Archaeological engineer Arthur Posnansky spent decades studying the site. He suggested the stonework implied knowledge of geometry and engineering far beyond what we attribute to pre-Columbian South America. Pumapunku was partially destroyed by looting and weathering, but what remains should not have been possible to build in the first place. Pumapunku used blocks that weigh more than a loaded freight truck. The next structure used jars that weigh up to a ton, carved out of solid stone, polished to a degree that requires tools we have not identified. This is number 1. 1. The giant jars of Laos, Xinjiang Province, Laos. Across the plains of central Laos, there are thousands of stone jars. They range from 1 to 3 meters in height, some weigh over 10 tons. They are carved from solid sandstone, granite, and limestone. Most are cylindrical, some have lids. The interiors are smooth and hollowed with precision. The stone is hard. Carving a jar this size from a single block requires removing the interior without cracking the walls. The walls are uniform in thickness. The rims are level. Some jars are polished to a reflective finish. Researchers have found jars with surface smoothness that suggests abrasion with materials finer than any sand in the region. The jars date to between 500 BCE and 500 CE, created by an unknown civilization. There are no inscriptions. There are no nearby quarries for some of the stone types, which means the jars were transported across difficult terrain. Archaeologist Madeline Kalani surveyed the jars in the 1930s and suggested they were used in burial rituals. Human remains and burial goods have been found nearby, but no one knows how they were carved. No one knows how they were moved. No one knows why this particular region and no other contains thousands of these objects. The jars survived centuries of weathering, looting, and during the Vietnam War bombing. Xin Quang Province is one of the most heavily bombed places on Earth. Many jars have shrapnel damage. Many are still surrounded by unexploded ordnance. And yet they remain, carved by people we cannot name, using methods we cannot replicate for purposes we can only guess. 15 structures, 8 countries, one thread connecting them all. They should not exist, not with the tools available, not with the labor force recorded, not with the knowledge we thought those civilizations had, and yet they are standing. The stones are real. The measurements are exact. The alignments still work. That gap between what should have been possible and what actually stands in front of us is the only mystery that matters. Which structure was the most impossible to you? Drop your answer in the comments. And if you want more stories about ancient knowledge we are still trying to understand, the next video will take you even further back.